Hello everyone, this is a live stream for Banner of Operations, BUSN 6630. And this evening, I'm going to be going through the quiz 1 and homework 1. And I'll just be working through, not some of the problems I may work all the way through, but I work them through to the end just to show how to work through them. And so this video is just going to be approaching the quiz and homework. Now, the reason I'm doing it this way is the last week the lecture was going to be over the introduction, introducing the material, going through the material. Today I'm going to focus on quiz 1 and homework 1. I was going to go deeper into the material like nonlinear trends, but we can do that later. For now, I'm just going to focus on the application of the material we did last week for quiz 1 and homework 1. Okay, so let's bring up Canvas. And here's Canvas and the home page. And so if we come down here to forecasting weeks 2 and 3, and there's where we are under the videos. Notice I have the forecasting video, the live stream video. That was the lecture. Now, right under this, I'm going to have the live stream video of the homework. So this will be right under there. So that'll be a video homework for forecasting. And notice in the Canvas, I went ahead and put the quiz 1 questions, the homework 1 questions, which we'll cover this evening, and I'll cover them on applying the material, this is a lecture, and I see the application of these two, quiz 1 and homework 1, on how to apply it. And then assignment memo, we'll cover that probably next week once we've done the quiz and homework, and I'll talk about why I'm doing that the week later, because some of these problems really apply to the assignment memo. Okay, so that's why I'm doing it this way. Now, if you go back to the home page, and then you go to down here the website, mdharper.com. This is my website. You go under Operations Management. And as we come down here, we have the videos. Now, this introduction and break-even analysis, I went over that 2 weeks ago, I think. Last week, I covered a lot of this material, but not all of the material. So today, I'll be focusing on applying it. And so even though I don't go into these videos or into these Excel spreadsheets, you can sort of use them. But what I'll be doing today is actually pulling up a spreadsheet and working from scratch. Well, if you can work from scratch and solve it, you can download some of these Excel spreadsheets. This will be helpful then in solving and knowing what you're looking at and how to solve and how to put the numbers in. So that's what I'll be doing. That's what I'll be doing this evening. Okay. And so people are starting to join us, and so I'll wait a few more minutes before I get started, so that we can have plenty of people here. And also on the under the videos here, downloading the quiz 1 and homework 1, and these videos. If we go back to here. One thing I've noticed, if you download some of these Excel files or videos, sometimes they don't download directly like this doesn't. But if you right-click, someone was telling me this, which I appreciate it. If you right-click and then you open the link, let's see here. It's not even there anymore. An open link in a new window like this. Then all of a sudden you can open it then you can open up the Excel spreadsheet. It's on my other screen over here, and there it is. And so I could have used some of these things generating it, but I'm going to generate everything today just by my from just an Excel spreadsheet. Okay. So there we are. Do quiz 1, then homework 1, and using Excel. Okay, that's kind of like an introduction. I see we have a number of people that have joined us, and so now let's get started with quiz number 1. So let's bring up quiz 1. And as we come through here, quiz 1, This first one is just general statements. This comes right out of the lecture last week. And so we talk about the time, and also it comes out of the videos. Again, if you go back to the, come back to the video and forecasting, this first video, then we'll talk about that also. Okay, so that also answers these questions, a lot of these questions. Okay, quiz 2. Notice how I do beginning 2, 3, 4, 5, 6, 7, 8, 9. I give a problem here and I solve the problem, really simple problem just to get into it, just to get used to the mechanics. Part of these questions in this quiz is just getting used to the mechanics of forecasting a little bit, because some people may have never seen it. Some people are used to it, some people have never seen it. The second reason is some people have never used Excel. So it's getting into using Excel. Here's how you go back and forth between Word and Excel. And then the third reason for doing it this way is once you have it, then the second question is going to be more of understanding the terminology and the relationships behind it. Okay. So, Craig, I would recommend, here the chat, I would recommend doing the quiz before the homework, because the quiz, and you'll see here, I'll do both of them. The quiz is more mechanics. Like the first question here is going to be mechanics, just getting an answer. The second is terminology and definitions, right from the lecture. But then the homework, then I start applying it. There's a scenario, and you work through the scenario. And we'll do that this evening. Okay, so let's do this one. Consider the annual time series, 5 years. What is the forecast for year 6 using a moving average with a window of 4 MA4? Okay, so let's bring this up here. Now let's open Excel. As I say, I want to open Excel and then just a blank workbook. Here we go. Let's make this large so you can see it. And then we'll bring this down. And so let's get this data from the Word file into an Excel file. And so you highlight this. Let's reduce this. Let's highlight this. Control C, copy. And let's come down here and then, well, let me right click. Let me go ahead and just do Control V, paste. And what I was getting ready to do is Control C and copy it. And then you can come down here. Let's notice these are row vectors. Now, sometimes Excel functions will work with row vectors, but usually they're concerned with column vectors and they consider things in columns. So right here, I'm taking this row vector. I highlighted it, Control C, copy it. Come down here. I'm going to right click and then transpose it. Okay. And then right click again just to be safe, and then right click and paste just the values. And the reason I do that is, it's not in this case, but sometimes, I don't want to get into the reasons why, but sometimes when you Control C and copy and paste, it'll paste alphanumeric instead of numeric. And so some of these numbers may be alphanumeric, and so you get the wrong answer. Anyway, so we have these. Now to get the moving average, MA, let's see here, let's bring this down. An MA4, okay. So if I want the MA4 here, forecast, okay, then what I will do simply is take the average of the last 4 numbers. 1, 2, 3, 4, in parentheses, and then return. And notice, if you've never used Excel, notice I have C8. C is the column, and then 8 is the row. C8, that's, there again. Oh, I'm glad I did this. It's C8 through C11. I didn't do the 2. Ah, mistake. So I want to left click and drag. I want all 5 numbers. Oh, no, I don't. I want the last 4 numbers. Well, if I want the 5 numbers to do a 5. If I want the 4 numbers to do a 4. Well, which one do I want? Well, it's an MA4. So we only do the last 4 numbers. Okay. If I press return, that's going to be the answer. I'll let you do that. Okay. And also, MA4 is not the first 4 numbers. It's the last 4 numbers closest to time period 6. Okay. That's that. Let's come back. And now we say, then we have questions. And these come right from the lecture. They're just definitions of terms. Okay, number 4. Consider the weekly. Okay. Should we also submit the quiz on an Excel, or can we use a Word doc? Submit? Neither. Neither. Remember the first week I went through the syllabus. And let's open this back up. Hopefully this is not a problem for people. When you go to the, let's back up here. When you go to the quiz, there's the quiz. You can download the quiz, and that's what I'm looking at now. I'm looking at the answers. Once you get the answers, only then do you submit it. And when you submit it, you notice you're not going to have any answers here. It's just going to be letters, A, B, C, D, E, A, B, C, D, E, A, B, C, D, E, where you get the answers A, B, C, D, E before you submit. And then when you submit it, you just click A, B, B, A, B, whatever the answers are. And so you don't submit it. You don't submit an Excel file. Don't submit a Word file. You submit it through Excel you set it through Canvas right here. That's how you submit it. So make sure that you do submit it correctly, because if it's late, you get a 0. So be very careful with that. Okay, let's go back to here. And so we're looking at, go back to here. Notice, see, you get the answer. Let's back up here. Whatever that answer is, the answer is either going to be A, B, C, D, or E, none of the above. One of these statements are correct, or none of them are correct. The answer is A, B, C, D, or E. None of them are correct, that's A. 1 is correct, that's B. 2 is correct, that's C, etc. So that's how you submit it. Okay. Okay. Is there a formula that automates moving average? Formula. Well, that's pretty much what this function is. It's just average you average the last 4 values. I'm not sure what you mean by formula. It's the average of the last 4 values. The lecture last week had an average, so I'm not really sure what that would mean, what a formula would be. It's an average. You sum the numbers, divide by the number in the sum. Out of curiosity, does Excel have an MA function? Actually, it probably does somewhere. Good question. It may have with an add-in, like if you look at the data and you add in data analysis, it may have a moving average. Yeah, see, it has a moving average right here. And so you can have input range and then the data label. So yes, you can. But you can do it by hand and know exactly what you want. You can go through the actual function within Excel. But this is an add-in. This doesn't come with these 2 menus. You have to add it in through the file. And the way you add this in, and we'll look at Solver here, I think the next topic. We'll look at Solver next topic. These are add-ins, and so I'll talk about add-ins next week. Okay, now then, let's see here. Should we consider this is not a stationary time series, hence is not moving average? We consider this, that this is not a stationary time series, and hence, well, Becca, yes. Do we submit the homework the same way as a quiz? Yes. I think you and I were asking the same question, Dana. Oh, okay. You probably were. You probably were asking the same question. And that's why we have people, sometimes students can answer the question better than me. Okay. When you think of a function, I think of, well, anyway, yeah. Okay. As far as stationary, when you ask for a moving average, you're assuming a stationary time series. So we're not going through the 5 steps. We're just looking at the techniques. So this quiz is just looking at the techniques, and that's all. The homework is getting into more applying this material. So this is just mechanics. Okay. The weekly time series, and here is 12 weeks worth of data. Week 15, and notice week 15, using simple linear regression. And so I'm not really assuming a stationary, non-stationary, but if I'm using regression, then you would be assuming a non-stationary time series with a trend component. We're not getting into that yet. So again, let's take this, Control-C and copy. Well, one more point about the moving average. Is it possible to forecast using another forecast in linear regression? I'm not really sure what that question means. Or is that just moving average? I'm not really sure what that question means. Another forecast in linear regression. So I don't know what you mean by that. But let me go ahead and do this one, then we'll come back to this, and other people might understand what you're asking. On this one, let's Control-C and copy this. Let's come back to Excel. A new sheet, and then Control-V, paste it, Control-C, come down here and transpose it, Control-C, and then make sure it's numerical. Now we're doing regression, and this is going to be for 13, 14, 15, 16, etc. And so we want, I think, 15, but the way we do this, pretty simply, let's do it over here. Let's do it this way, just so you can see what I'm doing. This would be the intercept. This would be the slope. Equals intercept. No, the known y's are going to be these, comma, the known x's are going to be these. Make sure I get them all right this time. Yep. Okay. Press return. And then the slope here equals slope. Again, the known y's are these. Now I'm using these functions. There are other functions, but this is these functions are tried and true. And sometimes new functions they do things that you're not really sure of. So this one is going to be equal to the intercept, and F4 then will fix that cell. It's not going to change. Plus the slope. Again, F4 fixes those two, it's not going to change, times my week, which is time 13. So there's week 13, there's week 14, then week 15 is what I'm asking, and you can probably see what it is there, and that's what I'm asking on this problem. Okay? Sound good? Okay. And then we have the regression from the lecture. Okay, question 6 is a quarterly time series. And here I want the forecast for quarter 11. Notice this is asking for week 15. This is quarter 11. Okay, Control-C. Let's open up Excel back, a new sheet. And then come here, Control-V, and paste this thing. C, and then transpose it. Oh, I'm not going to transpose this one. I don't want to transpose this one. What I want to do is take 5, 6, and 7 and just make the 5, 6, and 7 down here. Okay, so notice what I'm doing. I'm blocking it. And so this is going to be year 1. This is going to be year 2. And so notice what I'm saying here is that it says quarterly time series where there's 8 quarters worth of data. So the first quarter is going to be, and let me center this, the first 4 quarters is year 1, the second 4 quarters is year 2. And so what I'm asking for is the forecast for quarter 11. Okay, so this is 8, and then year 3 would be 9, 10, 11. This one right here is what I want. Since I'm using the seasonal index approach, I'm assuming a stationary time series. There's no trend in here. And so I just take the average of those two numbers, which would be the average of those two numbers. Boom, boom. And then return. And I'll let you do that. Okay. And then we have questions and statements. Questions and statements about from the lecture. And then that's more just qualitative, and the lecture will answer those. Okay, and also that first video, as I mentioned, will answer these too. Okay, how are we doing here? 9, 8. Okay, a monthly time series, 15 months worth of data, and forecast for time period 16. Okay, the very next one, month 16, using exponential smoothing with a smoothing parameter of 0.4. Alpha is 0.4. Okay, let's take this now. Control C. Go to Excel. I'm hoping everyone is getting used to this, so I'll start going a little faster here. New sheet. A new sheet. Let's come down here. Control V, paste it. Control C. Let me transpose it. To be safe, let me post these things. And now I want an alpha. Make this large here. I want alpha of, I think it was 0.4, was it not? Let's see here. It was, yeah, 0.4. So 0.4. That's 0.4. Good. So equal 0.4. Then I copy this down all the way down. Okay, now I am 1 minus alpha. I just like to have everything in front of me to make sure that the numbers are exactly what I expect. So I'll put 1 minus alpha here, and I see what I have. And so now, to do the forecast, and here's the ES forecast. First of all, I copy this down, okay? And then it's going to be my time series times my alpha plus my forecast times 1 minus alpha. That way I can see exactly what I'm calculating. It's more work. It's not as elegant, but it's brute force. I see what's happening, and I know what I have. And so therefore reliability is more important to me than speed sometimes. Okay, and then we copy this down all the way down, and I want time period 16. And so if I copy this down all the way down to 16, that's going to be the answer. Notice how I did that. Just start copying right here. Just start copying this down all the way down to 16, whatever that number is going to be. And so then the answer is here. There's A, B, C, D, or none of the above. And notice I'm rounding to 1 decimal place. And so you round to 1 decimal place. And so the second decimal place, the 100th place, if it's 0.5 or more, you round up. If it's less than 0.5, you round down. Okay. 4 down. Okay. Okay, let's make this bigger. Okay, 9, and then 10. This is just going to be, again, this is just general statements from the lectures. Okay, now from the lectures, just to make sure everyone is on board, let's bring this down. Let's bring Canvas back. And first of all, this video, this is a lecture. This right here is a video forecasting of lecture. So pretty much everything I covered is going to be in here. This is more of a lecture. If you come back to the home, come back to the website, I'll say this again, Operations Management tab, come down to forecasting. This first video here, this will go over a good introduction to a lot of these terminologies and also demonstrations and things. So the video in Canvas is a lecture, is like an explanation. This is more of a presentation of the material. And so there I bring in examples and things and color code things. Okay, one's a lecture, one's a presentation. 2 different things. Okay, so this will also could be helpful, I think, too. Okay, now let's go to weeks 2 and 3. And now the video, let's go to the homework. Now I'm covering the homework now. Okay, let's bring up the syllabus. Let me show you what I'm doing here. I'm just covering the, here we go. Notice we're right here, February the 2nd. I'm covering the quiz, and that should be straightforward, just looking at things. But then next on February 14th, the homework is due. Well, I'm covering the homework now, so you have 2 weeks before that's due. Okay, and then next week I'll probably cover the memo, or maybe this week I'll cover the memo and then the quiz and homework for linear programming. But the reason I'm going to wait for the memo is because you'll see here the homework. Once you work the homework, that's the technical part that you would use for the memo. The memo is just a presentation. So next week I'll work the memo, but then it's up to you to present it. And I'll talk about that a lot more, not next week, on February the 16th. So that's why I'm just doing the homework today, but you'll have 2 weeks to do the homework. And you'll see what I mean. I hope people will go through and actually work the homework questions. Try them on your own, and then use this video to use them to go back and forth and how to work them. So I consider this a lecture. I also said I want to why 1 decimal if the data series is only 2 numbers? Okay, let's back up here to quiz 1. See which one. Oh, these right here. Yeah, this is one decimal place. This is the units place. That's units. That's a tenth place. Different. I'm saying here's the 1 decimal place here. Oh, we could. I see what you mean. We could round to the whole number. I could have. But sometimes, notice the 44.7, 44.0, and I just want to make sure that people did get the right answer. And so sometimes 44.7 people will truncate to 44, not round to 45. And so when I have a decimal place here, that makes the units place, that'll solidify the units place because then it's easier. It's easier. Basically, yes, Craig. My choice, yeah. For now, which is a very good point, Craig. In practice, you probably would not do this. You probably would not have a decimal place with 44.7. You'll just say 45. It's close enough, especially when you have when you have a single unit, you might have a decimal, but you got to be careful with your decimal places in practice, in business. And I'll probably say this again. But I've been in meetings where people will give a number. Okay, now I'm starting to tell stories, and they'll have 849.567. Okay, or they'll say 521. And that'll be their number. Okay. And when I was a young scientist, this scientist was doing this. He put it up there because he was doing the arithmetic. And so someone raised their hand and said, "What's the significance of 1/1000th?" He goes, "Oh, it's I just rounded it to that." Okay, what's the difference between 0.521 and 0.522? And they go, "There is no difference." Then why are you telling me that? And for the next 10, 15 minutes, they start going back and forth. And then another person joined that person to say, yeah, what if it was 525 or 520? Is there a difference? Then why isn't it 52? Why isn't it 0.5? Why isn't it just 2849? And so come to find out, and I was a young scientist, I was listening to this presentation. Wow, these people are pretty brutal. After the meeting, you network, and they go, they did not like his research. His research was sloppy, and they didn't want him to continue. And so they found something that they could attack, and they did, and he never finished his presentation because they didn't want to attack his sloppy work. They'll attack his sloppy presentation. Okay. I probably should have another seminar just telling stories about what I've experienced, but no one would come. Let's go on to homework. Okay, let's go on to homework. From then on, I was really careful what I presented when I did presentations because I was at a government research, and I did the same thing in business. Okay, now let's start applying it with the homework. Now notice I have all these videos here with all the times, and so 12 hours and 20 minutes of video instruction, and so I want to say you don't have to look at all of them. Years ago I started doing this, and people would ask me, could you do one of this, can you do one of this, and I kept adding and adding and adding and adding, and everything's there for different reasons, for different people in different industries doing different things, engineering and social sciences. And so I just kept putting more and more things in there. And so, but as we go through here, I tell you which videos apply to this part. Part A is videos 1 and 10. Okay? And that's what applies if you want to look at them. But here I'm going to go through it. And if you want to learn more about it and go deeper, then those videos will be a presentation. This is a lecture. The videos are a presentation. Good. Okay, let's go. And so now we're getting into scenarios. Questions 1 through 4. Here we go. Carla, chair of the forecasting committee, calls a planning meeting to discuss the forecast for year 10 using the annual time series of sales in millions of dollars. So here's sales in millions of dollars. Carla distributes the time series and invites Amy and Bob to the meeting. Well, there's more people at the table, but Amy and Bob were requested to come and bring forecasts. Amy used a moving average with a window of 3 since this has worked well in the past, and so what forecast did Amy report? Window of 3, you average those 3 numbers. That's all you do. Okay, and we've already done that in the quiz. Okay, Bob used simple linear regression since he suspects a linear trend for the future. What forecast did Bob report? Well, you regress the sales onto the years and then forecast time period 10. He used regression. Which one of those would be his answer? We did that in the quiz. Okay. In comparing the two forecasts, Carla asked for a tracking signal with a window of 3. And which of these statements are correct or none of the above? Okay, now we're going to have a window of 3. We're going to have a regression and calculate a tracking signal for time period 10. Okay, so that's part A, the first 4 questions. Okay, so let's go through this quickly. I'm going to go through it quickly because I've already done the arithmetic, but I'm going to go to the tracking signal. So here, let's open Excel again. Let's open another sheet here and put this in here. And let me go ahead and transform it again. Okay, and then increase this. Okay, now what I want here is going to be a moving average. Let's see here. Let's do a moving average. Let's do it up here. MA, oh, what was it? MA4? Was it 4? MA3. MA3, and then regression. Okay, this may be a problem for some people. Can anyone else not access the homework? Let me address this real quick, and also hopefully this will help for the rest of the semester. When you come to Canvas, notice on Canvas, let's back up here to the home. Go down to the modules. Okay. Now, when you go to the quiz here or go to the homework down here, notice this is not accessible because the homework is in week 4 and 5. But this is to submit the homework, not look at the homework. This is to submit the quiz, not look at the quiz. This is to submit the memo, not look at the memo. So this is not open. That's why under videos, this is open. The quiz can be downloaded here. The homework's downloaded here. The assignment memo's downloaded here. So I'll do that every single 2-week session, 2-week interval. So you'll be able to download them at the beginning of the forecasting, at the beginning of this back up here. Beginning of the forecasting, beginning of the linear programming, beginning of the aggregate planning, beginning of the inventory. But remember, looking at the syllabus here, notice this is not due till next week. You have to wait until that week before you submit it, but you can open up all 3 of these on February 2nd. You can open up Quiz 2, Homework 2, and Memo 2 on February 16th, but you can't submit it until a later date. So don't open up the submission, and that's why I separate them out. So you can see them, you can see the questions in the quiz, homework, and the memo early and start working on it to get the answers before you submit it. Okay, because when you submit it, you're just submitting the answers. You're not working them. Okay, good. Again, repetition is good. I think I mentioned that before. Repetition is good. Okay, now guys, see if it is locked, but go back on weeks 2 and 3 and you can download all 3 of them. Now you have a copy of them. Try that, make sure that, see if that works. Whoops, wrong one. Okay, here we go. So now I'm going to do the MA3, 1, 2, 3. Great, great. See, now hopefully, I'm sure there's more than one other person asking the same question, so hopefully that'll work in future weeks. Okay, MA3, 1, 2, 3, right here. That's going to be the average. 1, 2, 3, and then bring this down. And so there's my forecast. Now doing regression here, I'm going to go ahead and do it here. I'll go ahead and do it like I did it before. Intercept and slope. Equals intercept of all the y's and all the x's. And then the slope of all the y's, all the x's. And then make sure I have the same intercept and slope on each one of these, and then just kind of bring these things down. And I'm going to have year 10. And so the regression then is going to be the intercept plus the slope times the year. Because there's our forecast right there. Bring these down. And there we go. Okay, now to get the, whoops. Okay, now to get the tracking signal for a window of 3. So the window of 3, I want these last 3 right here. So let me box them in. Box. Okay, now I'm going to have the difference. D minus F, and then the D minus F. Okay, and this is for the moving average. This is for the regression. I just want these down here. I guess I could just bring these down here, couldn't I? Yes, I could. There I did. Okay, now then, D, there's D, minus F, there's F. For regression, D, there's D, minus F, there's F, boom. Then I bring these down. I'm going to bring this down to here and stop. At this point, I'm going to take the sum, I'm going to take the average, and then right here, this will be the mean deviation, this would be the mean absolute deviation, and this would be the tracking signal. Okay, the mean deviation is going to be the average. Okay, the MAD. Let me take this back. I have to do this a different way. Let me just delete these. Alt-ED is delete. Okay, let me move these over. I need the absolute values too. Move those over twice. So now, these are going to be the same. Okay, and this is the absolute value of this. And notice they're all positive, so they're going to be the same. There's no difference. And this is just D minus F. Okay, and this is the absolute value. ABS is absolute value of that, and that's just removing the minus sign. And then you bring that down. Now I can do the, now that I have these, let's go ahead and move these over. Now I can do the sum and the average. And this would be the mean deviation in MAD. And this would be the mean deviation in MAD. Okay, so this right here would be the mean deviation. This right here would be the MAD. This is the mean deviation, and this is going to be the MAD. Okay, but that's not what I'm asking for. So that's not what I want. I want the tracking signal, but I'm close. So right here, so the tracking signal, TK, and let me just erase these. The tracking signal is going to equal whatever. Let's bring this down. I'm going to put it here. Equals the sum. Well, I'm getting all messed up here. Sorry, guys. That's what happens when it's live. I try to go fast. Let me go slower so I don't make mistakes. This average is the mean deviation. This average is the MAD. Now the tracking signal is going to be this divided by this. It's going to be this number. Let me just put that divided by the @ sign, and that's going to be 2 stars. So this is going to be this divided by 2 stars. Okay, and the same thing happens here. That's the mean deviation. This is the MAD. Okay, but this right here is going to be the same. It's going to be the same as this. Okay, I'll let you do the sum and the averaging. And this is what I'm asking for, that ratio. So the tracking signal is a ratio. Sums of the biases divided by the variability. So it's technically a statistic. It's a standardized bias. It's a normalizer, not a normalized, standardized bias. Okay. Finally, since Carla, so one of these is right, or none of the above. Since Carla was concerned about causes of variability in the time series, during the meeting, Carla asked Amy and Bob to respond to their assumptions of components. How many statements are correct? Okay, again, this is going to come from an understanding of the definitions, terminology in a time series, stationary, non-stationary. And so, again, this comes from the lecture. Okay. Okay, part B is 5 through 10. Diane, Ed, and Frank work for a company that contracts. Let's see if there's anything in the chat. Good. Diane, Ed, and Frank work for a company that contracts all their business at the beginning of each fiscal year, so the demand time series will be stationary through the year. Although their company has seen growth from year to year, problems with their forecast have been increasing every year over the past 4 years, beginning with year 1 in the table below. Glinda, head of the forecasting committee, has called a meeting to discuss the quarterly forecast for next year. Before the meeting, Glinda collected and distributed the following data of past sales and requested each member of the committee to analyze the time series and bring suggestions for next year's quarterly forecast to the meeting. Okay, so let's do this one at a time. And like I said, we're going to be using Excel. Let's open another spreadsheet. Okay, and so let's come over here, and we're going to be using this. So let's take this, Control C, bring in Excel again with a new spreadsheet. Right here, Control V, and there it is. Okay, and I'm going to leave it this way because I'll be working with it different ways. Control C and then make sure it's numerical. Okay, let's come back. Diane reported using a random component to keep it simple and not to change the procedure of using a 3-point moving average from previous years. Notice what I did up here in the part A. I said Amy used a moving average with a window of 3 since this has worked well in the past. And so notice last week in the lecture I said look at the time series as a stationary. Look at the components, make an assumption, decide, choose your components. Then choose your technique. Well, Amy says, and here comes more of our application. Amy says, well, let's just use moving average. It's worked well in the past, so let's keep using it. So she's not really going through that process, is she? Okay. Bob suspects a linear trend for the future. And so he suspects it, but why don't you just plot it, look at it, and you can see. For example, if I took this, Control C, let's bring Excel back. For example, if I took this, pasted this, transpose it to get it to where I want, and then just plot this thing. What if we plotted it? Insert, come down here and plot. Look at there. That's not stationary. So I think, so notice how I did that. I did that quick, but you can see how I did it. Insert over here and then, but that's non-stationary. For sure, that's, okay, which one of these is going to have more accurate results? Well, Bob suspects linear trend. This has worked well in the past. Well, in the past, maybe it was stationary, but now it's not. Okay, just plot it, and you can see it. Now, I say that because so many times in industry and in research, people start talking about what techniques to use, what techniques to use. Just plot it. They look at it and go, oh, yeah, we've got to use this, don't we? Yeah, we do. How about that? And so it's really simple to do. It's not that hard. And it's kind of like experience. Once you know what works, then you understand why the simplicity goes much farther than all the theory, if you know what you're doing. And so, okay, let's go on. So in this case, Amy says, or Diane says, to keep it simple. Well, sometimes a simple solution goes much farther than a complex solution if everyone understands it, as long as it's reasonable. Okay, here we go. She's going to use a 3-point moving average. Okay, Diane reported using a random component to keep it simple, not to change the procedure from using a 3-point moving average from previous years. Glinda reminds Diane that using a moving average that assumes only a random component results in only one forecast value, which would be for the first quarter of year 5. Diane agrees, but recalls that the forecast for quarter 1 of year 5 would be the forecast for every quarter into the future until they observe more data throughout the year. And that's how we're doing it in this course. In other words, when it's a stationary time series, you're forecasting one data point. That's your forecast for every time period in the future until we get more data. Glenda asks Diane for her forecasts for quarters 1, 2, 3, 4 for years 5 based on a random component. And then so which one of these is the correct answer or none of the above? Okay, so let's bring in Excel again. So I've described here how Diane was going to use this. So let's come here, and I'm not going to work this all the way through, but I will allude to this and say, okay, if I'm using a moving average with a window of 3, then for forecast of quarter 1 of year 5, I'm going to go ahead and bring it down here, and then say this is going to be year 5. Get that forecast right there. Use a 3-point moving average. Use the last 3 data points, which are what? Which are these last 3 data points? Because the time series goes years 1, year 2, year 3, year 4. The last 3 data points before year 5 is that point, and that point. You average those 3 numbers, and that's what Diane is going to report. I'll let you do that. In other words, over here I can say average, and just take those 3 numbers, return, and you have it. Okay. Next. Oh, but also this the description here, what Diane gives you, I gave it to you so that you could say whatever that is, that's the forecast for quarter 2, quarter 3, and quarter 4. All 4 of those will be the same number. Okay, once you get 1, that's the same for all year. Okay, let's go on to question 6. Ed argues that seasonal and random components should be considered since seasonality in the sales data is likely. Actually, that's a good point, Ed. Sales data is historically, usually, notoriously seasonal, especially depending on the product, what you're trying to sell. But it's usually seasonal for one reason, for a lot of different reasons. But seasonal, it's usually seasonal. It's a very common component. So Ed argues, where's Ed? Ed argues that seasonal and random components should be considered since seasonality in the sales data is likely. A good point, Ed. That's true. Glenda asks Ed for his forecast for quarters 1, 2, 3, 4 of year 5 based on seasonal and random components. What forecast did Ed report if he was doing it this way? Okay. So now he wants seasonal and random. So now we bring in Excel. Since it's seasonal and random, you block the values. They're already blocked for you. And the seasonal contribution in quarter 1 is represented in all those numbers. So then for year 5, this will simply be the average of all the first quarters. Okay, that's going to be the forecast for quarter 1 of year 5. And it's going to be the same once you get that. Then you just copy it over, like this. It's going to be the same for each one, because the average of those 4 is the forecast. Those 4 is the forecast. Average of those 4 is the forecast. I'll let you do that. Okay. So that's going to be his forecast. That's going to be the answer for Ed. And then Frank proposes to investigate the possibility of random, seasonal, and linear trend components after looking at a plot of the data. Okay, Frank. Well, I would like to believe that Frank took my course. Craig, you're right. I'd like to believe that Frank took my course. He says plot the data. He plots the data. And so let's see. What happens if you plot the data? Let's look at this real quick. Okay, let's do this. Insert. Let's see here. Let's look at here. Let's see if this is, yeah, look at this. Boom. And so here is year 1, year 2, year 3, year 4. And notice here's year 1. There's year 2, year 3, year 4. Does the pattern repeat every year? Yes, it does. It's seasonal. But year 1, year 2 is greater than year 1. Year 3 is greater than year 2. year 4 is greater than year 3, every year it goes up. That's a trend component. That's a trend. So you think, oh, okay, well, let's kind of reduce this down into some and move it over here out of the way. There we go. But suppose we wanted to see the actual time series. Okay, so what I would do here is take this, let me Control C, and let's copy it again down here. And let's just make this, instead of a table, a matrix, let's make it into a vector. Okay, and let's just go 1, 2, 3, 4. Okay, and now this is going to equal this, right? And this is going to equal this. I want this to be down here. I'm just going to start building my vector, okay? And this is going to equal this. And so I'm going to come over here like this. No, I don't want this. I take that back. I want this to be equal 1 plus that. So I'm just going to have, this is going to be just a time series. Okay? And so now I'm going to take this right here and just copy this down, if I can get to it here. Copy this down a ways till it goes to 0. Went to 0 way back there. Went overboard here, guys. Went a little bit over. There we go. Delete this thing. So now, oh my goodness. Take it easy there. Okay. So now this is going to be my time series right here. So if I take, this is my time. And this is my time series. Okay. So then if I take this, Control, Shift, down arrow, and then I'll say insert this thing, come over here. Let me take a graph, and there's a time series. Whoa, look at there. Okay. Is this thing going down? Looks like it is. Boom, 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 boom. Yeah, look at that. Think there is a trend here. 1, 4, 4, 4, and 4. Okay. Is that right? That doesn't look right. I got a problem with that. No. Oh, I do have a problem with it. That does not look right. And it's not right. Remember the first lecture I said, sometimes it doesn't feel right. That does not feel right. Turns out it's not right. Okay. This is live stream, so I made a mistake. I plotted the years, not the quarters. So I have to take these numbers. I'm going to do this just to show you how this is done. I'm bound to determine to do this. I need to transpose it. Whoops. Let me take this back. Okay. Let me take this again. Uh-oh. I froze up my Excel. Okay. I'll go ahead and save it. Okay, now let's see if I can get it. Oh man, I froze it up. Froze my Excel. Let me open Excel again. Get another one. Start all over again. Sorry, guys. Taking longer than I want. I went too fast, and it got confused. Control C. Bring it up here. Control V. Okay. Control C. Transpose. And there it is. Okay, now I got it. Oh yeah, because it gets confused because of the formatting in there. Take away. Okay, now we have the quarters. Now we have the time series. See, I was going across the years. Now we have the time series. So let's just go 1, 2, 3, 4, and this equals 1 plus this, and that'll just bring it down. And this is going to equal this. Bring this over. And by the way, this is how you make a vector out of a matrix. And then you bring this down ways to right here. That makes much more sense. And now let's take this. Here's my time series. Now I can do this. There we go. Now when I plot this thing, there we go. That's what it looks like. That makes more sense. That now I feel right. It feels right. Da-da-da-da-da-da. Because when I plotted this, remember, this looked right too. See? And notice every year, I'm clicking too fast here. Insert this and boom. There we go. So every year it comes down. Well, it has to come down every year, and that makes sense. So I could have transposed the data, but I just want to go step by step. So there's a time series right here. Okay, so there's a trend, and it's seasonal. Okay, so therefore, let's back up here, and so therefore, Frank, he plotted it and says there's a trend in there. There's a seasonal trend. So now, what forecast would Frank report? Okay, let's bring this back. Well, now that we have this up here, let's go ahead and add some rows in here. Control plus. Okay, now we know there's a trend, so we want the trend. Let's just make these 1, 2, 3, 4 equal the slope is going to be the trend, which is the y's and the x's. Okay. But actually, all I'm asking for is the forecast, right? All I want is a forecast for 1, 2, 3, 4, year 5. So I tell you what I'm going to do. I'm going to do this. Do it all at once. Intercept of the y, comma the x's, then F4 to freeze it, plus the slope of the y comma the x's, F4 to freeze it, times, let's see, it's gonna be year 5. There we go, year 5. And so then, well, I didn't want to return on that one. So I wanted to show you the whole thing. And there it is. And then once I press return, which I just did, okay, and then you can copy that, and there's going to be the forecast for Frank. Okay. And we could have done it. We could have done the trend there, the intercept there, the forecast, and the index. We could have done that, but I didn't. Okay. Oh, and then Glenda asked questions Diane about her assumption. You based your forecast. Let me see if there's any chats. Great, guys. Good job. Good job. Glenda questions Diane about her assumptions. You base your forecasts on a random component, which implies a stationary time series. That's correct. If you use a window of 4 instead of 3, what would be the estimate of the stationary mean from your moving average? Oh, so Glenda is throwing in some terminology here to see if Diane knows what she did. Well, when you take an average, a moving average, that's estimating your stationary mean. And so she's saying, what would be the estimate of your stationary mean if you had a moving average of 4? How would you do that? Well, very simply, you would average the last 4 values. That's all. So Amy averaged the last 3. You just average the last 4 values. That's all you do. The average of those last 4 would be an answer there, or none of the above. Glenda questions Ed about his assumption. If the time series has a seasonal component, then what are the seasonal indexes that correspond to your seasonal forecasts? Good question. Okay. Why would Glenda want to know that? Because knowing these indexes, she can use that for future analysis, just like we did in the lecture last week. Okay, so we can come down here, make this big. Did I do that somewhere? So you do this. Let me go ahead and do it. Here's the slope, comma, the x, F4 to freeze, and then copy this over like this, and then take the average. Okay, and then once you take the average, this is the seasonally adjusted trend. And then to get the seasonal indexes, it's going to equal this divided by the average F4 to freeze. Return, that's the seasonal index for quarter one. Oh, I did it. And then you do the same thing for 2, 3, and 4. And that's what Glenda is asking. Well, I've already showed you 1.5. So either A is right, or D is right, or none of the above. So the other three have to be right too. So you have to do the other three. Like I said, I did this. Equal this divided by this, F4 to freeze. And 1.5 is the first one. See, 1.5, 1.5. But you have to copy the other to get the other three. And I'll let you finish that. Now, Glenda questions Frank about his assumption. Looking at a plot, and we just did. Remember the plot up here somewhere? It's here somewhere. Here it is. Looking at the plot, there it is. Whether it's a stacked plot or a line plot, looking at the plots, there is a decrease every year from quarter one to quarter four. Why isn't the linear trend negative? There's a negative trend. And so, well, how would you answer that? You're right. The linear trend from year to year is negative. Okay. From year to year is negative. From this year to this year, it's negative. From there to there is negative. There is negative. Okay. Is that right or wrong? A non-stationary time series cannot have a negative linear trend. Is that true? A seasonal component can only exist with a positive linear trend. Is that true? Within each year, there are negative patterns between the 4 quarters, but linear trend between the years is positive. Is that true? I'll let you answer that one. Okay. Now let's get a little deeper. There are some basics. Now we get into some analysis. Okay. 2 time series are being considered and both contain random, seasonal, and linear trend components. However, the character of the linear trend is sought. Okay, I think I said this. The trend is either a step function or is a continuous trend. So the question is, which one of these time series is a step function and which is a linear trend? I mean, a continuous trend. Okay. Now, it's kind of hard for me to tell you how to do this, so I'll just do it and I'll show you how to go through this and how to do it. I did it in the lecture, but I explained it in the lecture, but here I'm going to demonstrate it. Okay, so first, let's copy all the data. I am unclear on how the moving average affects the stationary mean. Stationary mean, not just the average of all the values. Yes, I didn't say it was, I said it estimates the stationary mean. In other words, the stationary mean theoretically is like a population parameter. Okay? In other words, if it's the stationary mean in reality. We don't ever really know what that is, but we're assuming that it exists. Now we have a moving average. That average estimates that stationary mean. And so we're saying that is an estimate of our stationary mean. We're going to use that estimate into the future. I think that's what the answer, I think that answers your question. Back to question 8. Boom, boom. Yeah. You base your forecast if you use a window of 4, what would be the estimate of the stationary mean from your moving average? So it's an estimate. It's not the real, it's just an estimate, because you're taking a sample. Hopefully that's clear. If it's not, ask again. We'll go back. No, it won't be the same in this case, because let's back up to the time series. Question 8. Whoop, I just passed it. Where's question 8? 5, 6, 7, 8. So we're looking at this time series. Okay. So what question 8 is saying is that, oh, you used the average of those 3 numbers to estimate the stationary mean. And so then you say, wait a minute. Glinda says, what if you use those 4 numbers to estimate the stationary mean? What would be your answer? Okay, there we go. Good. Okay, let's come back to this. Now here comes some real practical, very, very practical. When you need it kind of thing. So let's start over again. Let's come this, Control C to copy it. Let's bring Excel back. Let's use this one. Let's open another sheet. Boom. Bring it here. Boom. Let's see if we can work with this. Control C. Well, I already have the columns here, but I'm going to come down here. I'm going to put it over here. I'll make another one here. Okay, there they are. Just the values. Just the facts. Now, this is quarterly data. Okay. And so, if you recall, let me go back to the lecture. If I have the lecture here somewhere, I have to go back to the lecture, and let me show you what I'm getting ready to do. And I'm getting there. Got so many things open. There we go. Okay. Coming down here, this is the lecture that I did last week. If we come down here to the examples that I did, and here we go, the decomposition. Here's what I'm doing on the decomposition, pages 213 and 14, is that I'm going to take this, I'm going to have a time series, I'm going to block it, get the indexes, seasonally adjust it, plot it, and see what kind of a trend. I either have a continuous trend or I have a step function. And so what I'm getting ready to do is just go through this procedure to see what kind of trend we have. Now I'm doing this to show the nature of the trend, but this process, you'll do this just to see any trend, to see what the trend is, because the trend may even be a little bit nonlinear. Okay, so this again is a very practical exercise. Okay, so where was I? There we go. Okay, so I have 2 time series here. Let's see here. I'm going to have to block this. So let me take this and come over here. Let me come down here and then transpose it so I can block it. And let me show you how to block it. Let me take this one and move this down. There's 16 of these. It's quarterly data. There's 16 of them. So we're going to have 4 years worth of data, right? So this is going to be year 1, year 2, year 3, and year 4. Okay. Well, this starts on quarter 5. This starts on quarter 9. Oops. And this starts on quarter 13. There we go. And so there we go. 1, 2, 3, 4. And there's our time series in block fashion. Same over here. This is going to be 1, 2, 3, 4. This is going to start with quarter 5. And this is going to start with quarter 9. And this is going to start with quarter 12, or 13, I mean. Okay. And then we bring those over. 2, 3, 4. So there's our time series right there. And so these are the quarters, and these are the years. Okay. Year 1. And then I'll say year 2. This is going to be year 2. I'll tell you what, I'm not going to do that. I'm just going to say 1, 2, 3, 4. Okay, so now, and so if you plot these things, I'm not going to plot them, but if you plot them, and this is time series 1, let's see where I'm at here. Yeah, this is time series 1, TS1, and this down here is time series 2, TS2, 1, 2, 3, 4. Okay, so now you have this, and so the question is, we want to, let's take these right here, and copy these, bring them down here and do them again, and paste them. Paste the values. So what I want to do is to seasonally adjust them. Okay. So I'm going to go through this. I need my slope. Okay, it'll be these, comma these with F4, and copy them over. Actually, you know what I'm going to do? I'm going to cheat and just do this, because it's the same thing. Okay, and then I'll take the average of these, and that's the seasonally adjusted trend, and the average of these, and that's the seasonally adjusted trend. Now before I go, and then the indexes, seasonal indexes, and that's going to equal this divided by this F4 to fix, and then copy it over. Same thing here. This is the trend, and this is seasonal indexes. And this is going to equal this divided by this F4 to fix it and copy it over. Now at this point I want to pause and say, notice that both of these time series have the same slopes for every quarter and the same indexes for every quarter. They're identical. So looking at this, you say time series 1, time series 2 is identical. It's the same. The slopes are the same for every quarter. The seasonal indexes are the same for every quarter. But is the trend the same? No. The seasonal trend is the same. The seasonally adjusted trend is the same. But what about the trend of the time series? Okay. So the way to do that is you take the seasonally adjusted, let me just say, the seasonally adjusted time series. And over here, I want the seasonally adjusted time series of 2. Okay, so I'm going to have 1, 2, 3, 4. And over here, I'm also going to have 1, 2, 3, 4. So I'm going to have, I'll divide this, divided by my index, F4 to freeze it. This will be the first time period divided by, divided by the index, F4 to freeze it. And this equals this, divided by the index, F4 to freeze it. And this will equal this, divided by the index, F4 to freeze it. I'm going to do the same thing over here. Equals this, divided by the index, F4 to freeze it. This equals this, divided by the index, F4 to freeze it. I do the same thing for the third quarter, okay, and then the same thing for the fourth quarter. Now, if I was doing this in a video, you wouldn't see all that. I would just break and then come back and say, I did all that. But you see exactly how you do it. Copy this down, and there's my time series. Boom, boom. So let's go 1, 2, 3, 4. 1, 2, 3, 4. And so this time series right here, insert. Well, let's make a time series. Let's actually do the time series. Okay. Now remember, these are the quarters. These are the years. Okay. We can probably see this is going to be a step function. This is not. But let's go ahead and plot them. So Control C, come down here, transpose it. Whoops. Control C, come down here, paste the values. Control C, come down here, paste the transpose. And there they are. So now this will equal 1 plus this, and this is going to equal the next one over there. Copy that over, and copy this down until we hit 0. Oops, too far. And here's my time series 1. Insert, data, boom, and there's my, whoops, let me stop this. Let me do this. There we go. Insert, this, and data. And there's my time series 1. It looks like a step function to me. Yay, that's so cool. And isn't that beautiful? And then over here we do the same thing. We take this, Control C, come down here, paste the values, Control C, transpose it, just to make sure, okay, equals 1 plus this, and this is going to equal this, and then copy this over to the third one, and then copy these down to here, and there's my zeros. And then right here, up, let me take this, and then insert, and then there's my nice continuous trend. Yep, it is so helpful. And actually, Vijeta, yes, as far as learning Excel, the thing of it is that once you have done this, and if you do this over and over again, then you'll just create a template. You take the numbers, put them in there, boom, you have it. Because I'm doing this step by step, hand by hand, step by step. But then you can create a template or even a macro, and then you could put all these together, and boom, it's done. Okay, but you know what you're trying to do. Now, every once in a while, you'll have a special maybe a command within a canned program that'll do this for you, as long as you have this kind of data. But what if you had monthly data or weekly data? Or what if you wanted to have monthly, weekly, monthly, and you want to do this at different parts? And so you know how to get to it. You know how to get to it. When all else fails, I'll ask my wife. For the predicted year, last year, is the trend linear with a slope, even if the function, step function? No, for the, see, that's the thing. If you want the forecast up, well, let's go on. Good point, Omar. Notice what I'm asking here. Is it a step function or a continuous trend? So I just did that for you. The question is, what is the forecast for 17? What is the seasonal forecast for 17? And what's the seasonally adjusted forecast for 18? Okay, so the seasonal forecast, you go through the template just as we've done before. I just plotted them here. And so this is time series 1. This is blocked. Okay, and notice this is the actual yep, this is blocked. And so right here you take your slope, you take your forecast. And down here, you do your forecast. In other words, you'll do equals the intercept of this, comma this, F4, plus the slope of this, comma this, F4, times the 5th year, return, that's your forecast for the first quarter of year 5. I'll let you do that. And then you copy that over to get the forecast for years 2, 3, and 4. And you do the same thing here for 1, 2, 3, and 4. But here I'm asking for 17. Down here I'm asking for 18. This is the forecast. And then you do the same thing down here for the seasonally adjusted forecast. Do the very same thing down here. Again, you get your forecast here, and you get your forecast here. Just like we did before. Okay. Oh, thanks, Raphael. It sounds like you know Excel better than I do. Oh, good. Actually, I've learned a lot of those functions. I used to use them. I stopped using them because every time they update and upgrade the software, they change the functions. And so I just go back to the basic ones because they rarely change the basic ones. They change the more combined ones. So I guess I'm old school. But I get there. I get there in in fine fashion, and it's pretty fast too once you get used to it. Okay, good. Well, that's that one. Becca, yes, you do. In order to see the trend, you always have to seasonally adjust it because seasonally adjusted takes away the seasonal component, and then you can see the trend. And especially in business and marketing data, sales data, and business data, you can't, and even economic data, you can't see the trend because it's hidden by, you have a general idea of the trend, but you really need to seasonally adjust it to see what kind of trend you actually have. Okay, that's when you usually do that. Okay. Okay, now then, 14 through 16. Let's see, what is this one? Okay, a company has historically used quarterly sales for one quarter as a forecast for the next quarter, MA1, or it's called the naive forecast. A lot of people do that. They don't have to worry about a technique. Whatever we had this quarter, that's our forecast for the next quarter. The company has usually been satisfied with this approach since the error was less than 10%. The errors from the forecast and the absolute value was not that bad. However, they have noticed that the error for the first quarter of each year was consistently too excessive. Kevin, the new MBA member of the forecasting committee, suggests possible components beyond random component that may contribute to the growing first quarter error since the presently used naive forecast implies only a random component. So I like to think Kevin took this course too. He says, well, if you're doing a naive or MA1, that's assuming a stationary component. Maybe it's not stationary. Maybe there's some kind of a trend in there. And that's why you're seeing these, and maybe it's a step function. Maybe that's where you're seeing the first quarter of every year. As it turns out, that's what's happening. Okay, here, just a side note here, Kevin made a very astute comment, a very correct comment, and he probably saw it and he was right. But be careful making these kind of comments because he made the comment, and so what's the very next thing? If everyone agrees with you, what's the next thing they're going to say? Having been charged with the analysis, Kevin collected the time series and did the analysis. They say, fine, do it. If you want to do work, make suggestions. If you want it done right, but you don't want to do the work, tell your neighbor to make the suggestion. Let him do the work. Okay? But that's company politics. Or ask a question. Why wouldn't someone do it this way? Why wouldn't the analyst do it this way? Okay? In other words, if you want to do the work, then you make the suggestion, then you can get charged with the work. If you don't want to do it, okay, that's beyond this homework assignment. Let's go on. Okay, what do we have? Is it trend? Is there seasonal? What's going on here? And then find the forecast, and then find these different values down here. Okay, let's do this again. We've done this before. Let's do it again. And that's why I'm working through it so you can see how it's done. Let's bring back Excel. Let's open a new sheet. Come down here and post it right here. There we go. Now on this one, let me go ahead and copy this. Let me keep it up here so we'll always have it. Copy C, and down here, paste just the values. Just the values. Okay. Now then, let's bring this up here like this. Okay, get rid of this. Okay, and this is going to be 1, 2, 3, 4, 5. There's going to be 5 years this time. Okay, so it's quarterly data. So this would be quarter 5. This would be 5, 6, 7, 8. This is quarter 9, and 11, 12, quarter 13, and then quarter 17. And so there's my block data. There we go. Okay. Now again, if we want to, and let's just call this a time series. Okay, if we want to plot this, insert, bingo. I want to do it this way. If we want to plot this, being here and then here, whoop. What am I doing here? I forget which way. Yeah, it's pretty, it's very, okay. So, let's see here. Let me see what problem I'm on. The company is usually, the company's, okay. Okay. So, yeah. I'm blocking it already. Let's take this, Control C, bring it down here, and then paste it. Okay, and then let's transpose it. Transpose. Okay, now let's bring this down here. Here's what I'm trying to do. Need to get my head into the problem here. There we go. And now let's plot this. There we go. Now when we plot it, we're going to see, insert this, plot this thing, and there's where we see the time series where, yeah, here's year 1, boom, year 2, boom, year 3, boom, year 4, boom, year, is exactly what Kevin was saying. Within a year, the error, if I use this first, let me make this larger. If I use this as a forecast for the next year, the error is going to be small, small, small. And then the first quarter of every year, it's large. And then it's small within the year. Then it's large from the fourth quarter to the first quarter. That's what's happening. You have a linear trend, but you have a seasonal component. But those indexes are really small. I mean, really close to 1. Okay, very close to 1, actually. Okay, so that's what's happening. And that's kind of what Kevin has suspected. And so he can plot this and actually see it. And so they're charged with, he collected the data, and so he's going to say, is it trend, seasonal, both seasonal and trend, in addition to random. And so you can see here that you can see it's trend and seasonal. So that's that question. But then he wants to have an analysis, a blocking analysis of the findings of the, first of all, what the forecasts are. And then down here, the annual trend of the seasonally adjusted quarterly time series, the seasonal indexes, the seasonally adjusted forecast, and the seasonal trend of the quarterly time series for the fourth quarter of every year. Okay. In other words, we're doing that same template, but we're doing it in such a way that we're just pulling different values off and interpreting it. Okay. And that's what I was doing up here. I was doing it up here. So let's take this and move it out of the way because we're done with this now. Move it over here. So now let's come over here to the time series, and I'm going to do this quickly because this is taking longer than I thought, but it's don't mind. So let's take the trend equals slope of all of these, comma, all of these, boom, boom, and then copy it over. And this is the average. Okay. And then this is the indexes. Oh, I didn't do that right. That doesn't look right. Did I do that right? Yep, I did. Good. Okay. Okay. Now the indexes. Equals this divided by, well, I got to get the average again. Equal the average to remove the seasonal component, and this will equal this divided by that, F4. There we go. And these should be really close to one another. Yeah, really, like 8.85 to 1.1. Very close, very close. Okay, then the forecasts. Okay, equals the intercept of this, comma this, F4, plus the trend times 6. Then copy this over, and there we go. So there's our forecast. Okay, and then we want to seasonally adjust it now. Seasonally adjusted value. Okay. Where am I here? Okay. Now let's do this for 1, 2, 3, 4, 5. I'm making sure my answers are right. I'm doing it the right way. This divided by my index equals this divided by my index. So I'm going through this. I'm going to go ahead and go through this so you can see what the answers are. And I'll double check to make sure I did this right, because as you can see, it's pretty easy to make some mistakes here. Make sure that's right. Yep, that's right. Make sure that's right. Yep, that's right. Yep, that's right. Yep. So let's copy this down. Okay, and then let's look at our forecasts. And that's the seasonally adjusted. Intercept of these, comma these, F4, plus slope, times 6. And then just copy these over, and there's a forecast for each one of those for the next year. Okay, make sure these are right. Good. 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 And then over here, we're asked a number of things. So you can get the forecast here, and I round them off to the units digit. The annual trend of the seasonally adjusted quarterly time series. The annual trend of the seasonally adjusted quarterly time series. So the annual trend of the quarterly, down here is the annual trend from here to here, and here to here, and here to here, and here to here. Okay, and that's the annual trend. The seasonal index for quarter 21. So here's, I think this is 2021 is right here, 1.14. That's right. The seasonally adjusted forecast for quarter 22, which I have, you can count it up down here. And then finally, the seasonal trend for the quarterly time series for the fourth quarter of every year. See the seasonal trend for the fourth quarter of every year. Here's the fourth quarter, the seasonal trend down here. And that's what I'm looking for. Now I'll let you pull those numbers off. So I've done the work for you so you can follow it, and you have this video if you ever go back to see how to do it. Okay, the next one is a little bit more straightforward. A company has historic, let's see if there's any chats. I'm not sure what that question is, Becca. Do you get the same values if you take forecast from row 17 and divide it by the season? Oh, I see what you mean. Yeah, you can go back and forth. Yeah, you can divide to go back. I think that's what you mean. You take the seasonal value, divide by the index to get the seasonal adjusted. Take the seasonal adjusted and multiply the index to get the seasonal value. I think that's what you're asking. Okay, a company has, and if not, ask it again. A company has historically used monthly sales for 1 month as a forecast for the next month. Okay, here we go again for stationary time series. The company has been satisfied with this approach except for the unstable behavior of the forecasts. Janine, the new MBA member of the forecasting committee, here it comes again, suggests using more data to stabilize the forecast. But the committee expressed concern about placing too much reliance on past months. Yes, Vega, you're right. Yes, you can. Take the seasonal data, divide by the index, and do the same thing. Yeah, that'll give you the same number. You're right. Okay. So this right here, a lot of people are concerned with, if we're going to forecast, let's don't take something decades ago. Let's take something relatively close. Okay. But then the company says there's a lot of volatility. The company has been except for the unstable behavior of the forecast. The forecasts exhibit too much volatility, and that volatility really makes it difficult to run operations. Okay, and so they want to stabilize the forecast, but they don't want to use a lot of data. So in moving average, remember, you increase your window to lower to dampen the noise and to lower the magnitude of the time series and stabilize it. But Janine, the new MBA member of the forecasting committee, suggests using more data to stabilize the forecast. But the committee expressed concern about placing too much reliance on past months. We don't want to go too far back. Janine then suggested exponential smoothing so that the weight of past data can be balanced with the stability of the forecasts. And what Janine explained was, we can use data, but as we go further back, we weight it less. And as we weight it less, we can balance that with the stability of our forecast. And so we can do both and not put too much reliance on past data, but also stabilize the forecast. We can do both with exponential smoothing. So the committee unanimously agreed with the proposal and discussed the initial smoothing parameter. And so Janine collected the data. Let's do this again. Collect the data, bring back Excel, open up Excel, and come down here and let's post it. Post it. Control C, come down here and post it again with just the values. Okay. And then after discussion, Janine got approval for a smoothing parameter of 0.3 and straightway obtained her forecast. Okay. And what did she find as her forecast for month 21? Okay, well, let's do that. Okay, let's make this big. Make this big. Okay, let's come down here. Let's copy this. Copy. Come down here. Transpose. Okay. And then let's bring this down. And here's our time series right here. And so let's go ahead and get rid of this. And now here's going to be our ES, an exponential smoothing. And our alpha is 0.3. Our 1 minus alpha is 1 minus 0.3. Whoops. Equals 1 minus 0.3, which is 0.7. Okay, and then I'll just copy this down. There we go. And I want the forecast for 21 down here. Okay. Okay, sounds good to me. Now let's just do it. And I mentioned in the lecture, it's easier doing this in Excel. This is going to equal the time series for the first, and now the forecast for time period 3 equals the data times alpha plus the forecast times 1 minus alpha. And then I just copy it down. Boom, 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 boom. That's all there is to it. I'm going to stop here and let you go all the way down to 21 to get the forecast. Okay, to go all the way down there to get the forecast. But then when you look at this, I can take this. Let me take these values here, plot it. Okay, let's go from 800 to. Let's reformat this. Double click and let's go from minimum is 800 and this will be 1100. There we go. That's a little better. So this could be 850, this could be 1050. Let's do that. Let's make it really big. Okay, this is 850. Whoops. 850. Whoops. 850 to 1050. Okay, then we just fill up the chart. Let's just fill the chart. Ooh, fill the happy little chart. Okay. Now then, the question, okay, I'm getting ready for the next question. You can do the forecast. Before Janine reported her results to the committee, she wanted to compare the current time series forecasts with more stable time series forecasts using different smoothing constant for exponential smoothing. In other words, what would she do? Increase, decrease? What should we do to have more stable forecasts? Okay. Well, the blue is the time series one. The orange, this second one here, and actually, let me let's do the marker. Let's change the marker here. The marker options built in. Let's make it something cooler. Let's make it more of a square. Do we want a square? Yeah, let's make this more of a 9. Yeah, let's do that. Okay. Well, I wanted all of them. Doggone it. Let's see. Wake up, wake up, wake up. There we go. I wanted all of them to be that way. Okay, marker. Do it again. Marker options. Automated. Built-in. Automated square. Make this a 9. Okay. Return. Okay, now we can tell the difference. Okay. And actually, let's make this black. There we go. And now let's make the marker black. Fill, solid fill of black. And then the border, solid fill of black. Okay. Okay, in other words, the blue is the time series and the black is the forecast. So what would happen if I increase or decrease alpha? We can see this here. And I do this in the video, by the way. You can look at the video and it'll show you this too. But what if I go down? 0.2, 0.1, 0.05, does it stabilize the forecast? There's 0.3. What if I go up? 0.4, 0.5, 0.6, does it increase the volatility? It's pretty obvious, okay? And so here you can actually see what's happening. And this is the kind of thing that I think Janine would probably present to the board and to see, say, look, we can do 0.1, 0.05, 0.02, 0.01. We can even do 0 if you want and just have a flat line. And essentially all that is going to be the very first, it's going to be the average. It's going to be the first data point, and that's going to be my forecast. We don't really want that. 0.2, 0.5, okay, 0.1, 0.15. In other words, they can figure out what they want, and they can look at the data. Okay. Notice the volatility in the data is pretty large. Anyway, so that's how you would do this question down here. 19 and 20. Okay, now then, here we're getting ready for the memo. So the memo is based on this problem. And the way you solve this problem is the way you would solve the memo. And so I think in 2 weeks, whenever it is, I'll be talking about the memo, but I'll use the memo data. But you'll see the memo data is very similar to this data. And the procedure is the same. So essentially, the last question of the homework is just like the question on the memo. Okay, at the end of their fiscal year, a consulting company wants, let me see if there's anything in the chat. Okay. At the end of their fiscal year, a consulting company wants a quarterly forecast for the number of contracts next year. So they want four forecasts. In their forecasting analysis, they examine the quarterly number of contracts over the past 3 years. Okay, and there they are again. If you were working for my consulting company, what would I accept as the best quarterly forecast for each quarter of year 4? What I mean by that is I want you to give me a forecast, but I want you to give me the best forecast. But I want you to give me the forecast as if you were working for my consulting company, because I know what you know. In other words, and I know what to expect. I expect you to plot it. I expect you to see if there's non-stationarity. If there is a trend. I expect you to see if there's seasonality. If there is, you're going to block it. And I expect you to put them all together. and create a forecast that puts all that together if those components are there. And I would expect you to tell me what components you have, and from that you've decomposed it, you've put the parameters back together, and you have your forecast accordingly. I would want to know that. And that would basically, it would take less than 2 minutes, less than 1 minute to present that, because I know what you're talking about. Okay? And one of these would be the forecast according to those guidelines. Okay, that's what I mean. And so this is really the only real question in this homework, because this is what you're going to get in practice, in business. They go, oh, there's a time series. Let's get a forecast. Okay, let's get a good one. Get the right one. What's the forecast? Well, let's do it the right way. Okay, who's going to do this? We'll let you do it the right way. Okay, so let's do it. Let's take this and I'll show you how this works. And this is pretty much how you do the memo. Control-C to copy this thing. Bring this back in. Okay, let's open a new window. Okay, come down here. Control-V and paste it. Control-C, let's do it again. But this time let's have the values here, the actual values. And let's, these are the contracts. This is going to be year 1, year 2, and year 3. This is going to equal this one here, and this is equal to this one here. And then we'll bring this over like this. There we go. Okay, now then I'm going to take this down here, Control-C. I'm going to copy it again right here, the data. I should make this bigger so you can see what I'm doing. Now, at this point, let's plot this. Let me take this and plot it. And so insert, like I've done before, plot it. And here we go again. I'm doing something wrong. Okay, get rid of this. And let's see if I can do it this way. So this is year 1, year 2, year 3. I keep forgetting how to do this. Sorry, there we go. That's how you do it. Okay. As we increase alpha for time series 2, is the trend following the time series 1? Any correlation there? If alpha equals 1, then the forecast is just the prior actual value, like a moving average of 1. That's correct. With how the math works. So yes, you're right. Actually, it's correlated with a shift of 1. Right, guys? You shifted 1, it's the same numbers when alpha is 1. And basically, that's called a phase shift. You have a phase shift of 1, and the autocorrelation function, you correlate it with itself. 1 would be a spike of 1. And that's used when you're doing spectral analysis. And some of you with engineering know what that's all about. Okay, so here's this one. Well, the autocorrelation function, for those of you who do it, is not the spectral analysis. You transform the autocorrelation function with a Fourier transform to get the spectrum. Okay, so here I plotted this, and here's year 1, year 2, year 3. 1 is blue, 2 is orange, 3 is gray, and you can see, why do we plot it? Is it stationary? No, it's non-stationary. There's year 1, year 2 is higher, year 3 is higher. Every year it gets more and more and more, so there's a trend. Also, the pattern is relatively the same every year, so I have a seasonal component. So what I would want to see from you is, 1, this is a seasonal component and a trend, okay? But you can also say it's linear trend and it's seasonal, but you can also here do this. Let me go ahead and copy this like we've done before. And this is equal to this. Bring this over. Let's take this into a vector. And there we go. And now let's take this and plot it. insert, plot. Okay, now you can actually plot this if you want and say, here's my quarter, up 3 and down 1. Here's 1, 2, 3, see. 1, 2, 3, 1, 1, 2, 3, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Again, it doesn't look right. It's not right. It's not right. Sorry about that, guys. Yeah, it didn't look right, didn't seem right. Oh, let me take that, bring that back. I didn't look right, and it's not right. Let me take this out. Again, I did the very same thing. Did the same thing as I did before. This needs to be transposed. Okay. Transpose this. Then this is year 1, 2. This is quarter 1, 2, 3, 4. Then I could say equal plus this one, and this is going to equal this, and this is going to equal this. Now we can do this. Bring it down. This makes more sense. Okay. Now we can plot. This is our time series, quarter 1 through 4. Again, I was doing the years. I didn't want to do that. Now I can insert a graph. And so this, there we go. This makes more sense. Down, up 2, down, up 2, down, up 2. So there's my 4 quarters as a trend. So there's my trend line. So that's my trend. You can see the trend here too. You can see the trend here too by the stacked years increasing, and here you can see it in a time series. Here's a stack plot. So either one. So now that we know that it's a linear trend and seasonal component, then we go in and we come back up here and we do the trend. Okay, we'll do the seasonal indexes. We don't need the seasonal indexes. Then do the forecast. Okay, and then this is what we're going to report. And we've already done this before. And I'm not going to do it again because I've done it over and over again. And then we do it. And so for this is the answer for the question 9, I think it is, or whatever the question we're on, whatever question 19. That's this question, and then 20 is just what types of components do we have. But for the memo, you're going to have something very similar, a different scenario. And you'll be going through this very same procedure. Now, I'll be going through this procedure again when it comes to the memo. But it'll be pretty much like this. And then I'll say, here's the kind of things we want to say as a group. You're charged with actually writing the memos. The response memo to the client, the tactical memo to the team, to the internal team. Okay, and we'll do the memo that way. But this is how you do this one. Okay. Now there is on this chat room, there is a lag time of maybe 10, 15 seconds. So before I start closing this down, let me ask you to take one last moment. Are there any questions about what I've done on this homework assignment on how to work either the quiz or the homeworks? Notice I've gone through, it's been a couple of hours. I've gone through step by step, made the mistakes. Corrected my mistakes. And I remember one time a student one time said, I kind of like the mistakes because it's one thing knowing how to do everything right. It's another thing knowing what to do when you make a mistake. I guess exactly. That's exactly right. And so I went through and oh, that's not right. That doesn't, notice a couple of times, that just doesn't feel right. That's what I said on the very first lecture. You get a feel for what the answer is, then you do the arithmetic, and it's got to feel right. If it doesn't feel right, back up and re-look at the numbers. I did it twice during this homework assignment because a lot of moving parts. Okay, and I years ago I had I realized that I wanted to actually go through the homework with you so you could see how to work it. To me, that fits in a university because there's where I'm coaching. Okay, but I'm kind of talking because waiting for another comment. If no one has one, no one does. So I think that'll be it for today for the quiz 1 and homework 1. Next week we start linear programming and the next topic. And I hope this helps. And we'll be doing this 3 more times. You're welcome, Sridevi. Again, good questions here. Dr. Harper, are we encouraged to work in groups for the memo assignments? And if so, to clarify, we need to so individual writing and submissions, not just one submission for a group. Exactly. And I emphasize that. I'll emphasize it again next time I talk about the memos. I encourage you to work in groups on what you want to say, and I'm going to work with you. I'll do the arithmetic, and I'll say, we should be saying this. We should be saying this as like this is a team. I'm part of your team too. I think we should say this and this and this. I'm not going to write it. You're going to write it, but I think we as a team should address this, this kind of thing. Okay, and so that's yeah. But then you write it yourself. Don't one person writes your own memo. So from what you hear, you put it in your words what you want to say. And maybe you agree with us and maybe you won't agree with us. Okay? Or maybe you want to say something a little bit different or something more. Okay? But you make it yours. So as we get together and we talk, you'll have all these ideas. You're the one who puts it together in a memo. And that's what the memo is going to be about. So the quiz and the homework is just getting the answers. Okay? Now the memo is going to be communicating. In communicating, you get all this information, and then what do you pull out and put in the memos? And I'll talk about that in more detail. Okay. I'm not able to get the red book. Is there an ebook? Yes. Yes, there is an ebook, sort of, kind of. The red book, I did have a red book, but I think they're all gone now. I'm not printing anymore because instead of having the red, I'm just putting it in Canvas. Okay? If you pull up Canvas, let's come back to Canvas. Where's my homework? Here's forecast, videos. Notice these lectures, download Word file forecasting. If you download this, then you click it here to download it, and then you open it. Whoops, it's over here. Boom. Okay. This is the same as the red book. I used to have a red book. You buy a book so you can carry it with you and take it with you. But I'm putting together another red book. And so I'm just posting these on Canvas as we go. So you'll have these as you go through. So this is essentially what I had in the red book. I put a few more things in. I'm starting to modify this and expand this for an expanded red book coming up probably this year or next year. So I said red book because there were some left, but if there's none left, you're going to get it anyway. And like you say, who said that, Craig? Like an ebook. It's going to be on the quizzes. I mean, it's going to be on the lectures for a Word file, and you'll have a Word file of it, not a PDF, a Word file. So you can do things with it if you want. Okay. Brittany, I ordered the red book this evening from Tivoli, free pickup at the bookstore, although I'm going to cancel my order. Okay. No memos on the new TPS, so TPS cover sheet, I hope. No memos on the new, I'm not sure what that means. No memos. I don't give examples, if that's what you mean, because I don't want people to write it that way. I want you to write it your way. So I give you ideas, and then you write a memo the way you would like to write it. And then what I'll do is I'll show you some memos. I'll black out the name. I'll show you some memos that people did. Okay. But also we'll talk about the memos a lot more probably in 2 weeks when the memos are due, on the week of the memos. Oh, Office Space reference. Sorry, my age. Oh, no cover sheet. No. In the syllabus, I talk about the. Where's my syllabus? In the syllabus down here, I talk about the memos. Again, repetition is good. Communication, quiz, homework assignments, memo assignments. Here I describe the memo assignments. This is in the memo. And all you do is have the response memo 1, 2, 3, 4. Your heading, and then a one-page content here, the memo. And all I want is just this header. The title in the header, title and header, and that's for the response and the technical memo. The response is to the party requesting the work, and the technical is to me or our team on how you actually, what you did to get the answers in the response memo. And we'll talk again more about this when we start doing the memo. Okay. Boom. Okay, you had said you will have an example memo. Actually, I said I would not have an example memo. Someone said, will you? And I said, no, I won't, because I don't want everyone to do it that way. I want you to do it your way. Will that be downloadable? Signing off. Thanks, Dr. Harper. Thank you. Yep, that's all I have for tonight. I tell you, if you have more questions, tomorrow night at 7 I have office hours. Friday night at 7 I have office hours. You can certainly ask questions then, and we can share screens and do same kinds of stuff we're doing right now. And we can have a Zoom session. I hope this is helpful. That's all I have for tonight. Again, this is fairly new for everyone, and I hope the stream and the chat room is helpful, and on how to work the lectures and also the homework. And next week we'll start linear programming. That's all I have for tonight. So between now and the next time I see you, I'll tell everyone, be careful out there, take care of yourself, be careful and take care.